Okay, we're in section 11.2, trapezoids, rhombuses, and kites on number 21. And our directions for 21 are to find each missing length. The trapezoid has a height of 8 meters, a base length of 12 meters, and an area of 64 square meters. What is the length of the other base? So our formula for area of a trapezoid is 1/2 of the height times the quantity base 1 plus base 2. So we'll substitute in our area, our height, and our base. And we want to solve for the other base. So I'm just going to simplify here. Then I'm going to divide both sides by 4. So let's see, 64 divided by 4 is 16. And if I divide by 4 on this other side, it cancels out. So then subtract 12, and base 2 is 4. So if you wanted to check this, you can substitute this back in here. So you would have 12 plus 4, or 16, times half of 8, so 4 times 16, which does equal 64. So 4 meters would be our other base. Number 23, for each figure, provided a justification showing that area is equal to half of D1 times D2. So for 23, our area could be broken up into the area of this triangle plus the area of this triangle. So basically, the area of this entire figure would be the area of triangle HGF plus the area of triangle HJF. So let's come up with an expression for the area of triangle HGF. Triangle HGF is half of its base times its height. So its base would be this length, which we know is D1. Its height would be this length because it's perpendicular to the base. So that would be half of D2. So if I simplify this, I take 1/2 times 1/2, I get 1/4 D1 times D2. So we want to do the same thing for triangle HJF. So triangle HJF, we can call this the base and this the height. So the base would be the same length as it is here. So we want to take half of the base, so half of D1 times the height. So the height, once again, would be this length right here, which is half of this entire length. So half of D2, and we get the same thing as we did before. We get 1/4 D1 D2. Now we can substitute that in for our area of the kite. So triangle HGF plus HJF would be equal to 1/4 plus 1/4 is 2/4, or 1/2 D1 D2, which is what we wanted to show. Number 25, Ashanti is in a kite competition. The yellow, red, orange, green, and blue pieces of her kite design shown are congruent rhombi. Part A, how much fabric of each color does she need to buy? So we need to figure the area of everything here. So for the red, the orange, the yellow, the green, and the blue, they all have the same dimensions because each of those would have a diagonal here of 6 inches and a diagonal here of 8 inches. So 6, 8, 6, 8 for each of those. The purple would be different. So for all colors except purple, our formula for rhombus is half diagonal 1 times diagonal 2. So we would have half of diagonal 1 is 6, diagonal 2 is 8, or 3 times 8, which is 24 square inches. The purple would be a kite with a diagonal 1 of 5 and diagonal 2 of 8. But it's still the same formula, half of diagonal 1 times diagonal 2. Only this time half of 5 times 8, which is equal to 20 square inches. In part B, competition rules require that the total area of each kite be no greater than 200 square inches. Does Ashanti's kite meet this requirement? Explain. So, for part B, we want the total area to be less than 200. So we have 1, 2, 3, 4, 5 pieces of the kite, each with an area of 24 square inches. So 5 times 24 will give me the total area of those 5 pieces, plus a piece of the kite, the purple part, is 20 square inches. So then we need to add 20 to that. And if we do so, we get 140 square inches. So, does Ashanti's kite meet this requirement? Yes, because 140 square inches is less than 200 square inches. Number 27, find the area of each quadrilateral with the given vertices. So let's go ahead and plot. these vertices. So we have 3, 0, 1, 1, 2, 3. 0 is W. 0, 3. 1, 2, 3 is X. Negative 3, 0, 2, 3 is Y. And 0 is at, or Z is at 0, negative 3. 2, 3. So basically what we end up with here would be a square. A square, you can remember back earlier in the year, different types of quadrilaterals. A square is in fact a rhombus because it has 4 congruent sides. So if we want to find the area, we use the area formula for a rhombus. Half of diagonal 1 times diagonal 2. So how long are my diagonals? Well, from here to here, that would be a length of 3 plus 3, or 6. And then from here to here would also be 3 plus 3, or 6. So substituting in, I have half of 6, which is 3 times 6, which is 18 square units. On number 29, the figure at the right is a trapezoid that consists of 2 congruent right triangles and an isosceles triangle. In 1876, James A. Garfield, the 20th President of the United States, discovered a proof of the Pythagorean theorem using this diagram. Prove that x squared plus y squared is equal to z squared. So we are proving the Pythagorean theorem on this triangle right here. This leg squared plus this leg squared will be equal to the hypotenuse squared. So we know that this entire figure is a trapezoid. We have our parallel sides. That would be base 1 and base 2. And then we have the side that is perpendicular to both of the bases, or the length, the segment that is perpendicular. This would be our height. So an expression for the height could be x plus y, or y plus x. So our area is going to be half of our height, so half of x plus y times the sum of our bases. Base 1 and base 2 is x plus y, or y plus x. Now to simplify this, I need to double distribute or FOIL my binomials here. So I need to take my first term times my first term, my outside times my outside, my inside times my inside, and my last times my last. And then simplify that. So I get x squared plus 2xy plus y squared. So that's an expression for the area of the trapezoid. Now, how else can we express the area of this trapezoid? Well, we have 3 right triangles here. If we add the areas of each right triangle, or the area of each right triangle together, those 3 areas combined would be the total area. So I have the area of triangle 1. Triangle 1, its base and height are its legs, and that's always the case for a right triangle, since the legs are perpendicular, so therefore they are the base and the height of